To what extent does burying something underground represent taking responsibility? And to what extent are future generations still going to be variously burdened with the leftovers and the legacies of these infrastructure projects that at least span 100 years in development and potentially need to be remembered for thousands and thousands of years into the future? My name's Thomas Keating. I'm a researcher in technology and social change at Linköping University in Sweden. Nuclear waste, and particularly spent nuclear fuel, poses particular challenges to human society, not least because these materials are difficult to detect. They're often invisible. Their radiation can't be smelled or tasted or touched. And the effects that they have on organic bodies and tissue, the harmful effects often are delayed in time, so things like cancerous cells might not be noticed until slightly after there's been exposure to radiation. So in Sweden and Finland, the plan has become to bury nuclear waste in permanent geological repositories for a stated time of 100,000 years. And the idea behind this, according to the experts, is that this provides a genuine long-term solution that doesn't require human intervention and monitoring to the problem of nuclear waste, and particularly spent nuclear fuel. It ensures that organic life doesn't come into contact with the nuclear waste, at least organic life. There'll be some microbial life down there, but not organisms. And it ensures that water and land, at least in theory, won't be affected or contaminated by nuclear materials. So in January 2022, the Swedish government approved SKB's plan for the spent fuel repository to be built in Forsmark, which is the final repository, geological repository for spent nuclear fuel. So the spent nuclear fuel repository will take about 100 years to be excavated and filled with nuclear waste canisters, which will be long copper, metal rods filled with spent nuclear fuel pellets. It's backfilled with bentonite clay and then concrete that's stored 500 meters underground in mostly granite rock. So sometime after the turn of the 22nd century, the repository is expected to be filled with nuclear waste, completely sealed, and all data and human monitoring and involvement, according to the proposal, will end, and then the waste will exist autonomously, passively, without any human involvement. The nuclear waste repository has the stated aim, according to its developers, that it must last 100,000 years. We're at the Hard Rock Laboratory. We're actually at this site because it's a test laboratory for the spent fuel repository that's going to be built and excavated in Forsmark. And this is really the place where SKB have developed the technologies and the materials that they want to use to store spent nuclear fuel, the most radioactive substance on Earth, underground for 100,000 years.
This is a research tunnel for research and also for technical development of techniques and machines, etc., that we are going to use in the final repository for spent nuclear fuel in Sweden. So we go to the 340 meter level. We're here.
So we're here.
But we'll go to 450. We are just going out into the ramp, and we're at the depth of 340 meters. And at the repository depth, we will have like smaller tunnels,
yes,
going on, looking like a fish skeleton, fish bone.
And this would be where the spent nuclear fuel would be delivered down in autonomous vehicles, is that right?
On some kind of vehicle, yeah. And we say that we're going to deposit, say, 150, 200 canisters a year. And this is what the canisters look like that we're going to put the spent nuclear fuel in. So it's 5 meters long. It's not really a meter in diameter. And the thickness of the copper is 5 centimeters. Inside here, there is an insert of cast iron, which holds the spent fuel elements. This is the canisters that will go down into the repository. And this one is empty, but for real they are going to weigh 25 tons.
How dangerous is nuclear waste in the kind that's going to go in the Forsmark final repository?
Well, if you handle it in the right way, it's not dangerous. But if you don't, it could really harm you. So that's why it's so important that we have all these measurements. We are standing over one of our deposition holes, which we have drilled here so that we can learn how to drill deposition holes. So if you look down, it's 8 meters deep and 1.5 meters in diameter. And we are going to have 6,000 of these deposition holes in the repository. And we are going to have 1 canister in every deposition hole. And before the deposition machine comes with a canister, we are going to put bentonite clay in the bottom, like a big, huge hockey puck. And then we're going to line the deposition hole with bentonite clay. And then it's okay for the deposition machine to come and place the canister. And then there will be bentonite clay on top as well. A lot of countries have the same idea as Sweden and Finland and France have, that it should be, you should put your waste in a deep geological repository, because that's where you have the most stable environment. No matter what happens on surface, you have a stable environment in the bedrock.
So it's all about stopping water getting to the copper?
Yes.
And then this whole area will be backfilled with concrete?
Yeah. So the deposition tunnels will be like 200-300 meters long, and about every 6 meter we will drill a hole, put the canister down, and then backfill.
And this is it. This is the final resting place for
Yeah.
that spent nuclear fuel to last 100,000 years.
Yes.
So I'm Anna Storm. I'm professor in technology and social change at Linköping University in Sweden. Today we have the privilege to be in R1, which is the space in which Sweden had its first nuclear reactor. So this is the place where it started, you could say, in the 50s after the Second World War, when many countries took up the nuclear race, trying to find out what this new technology was all about. And this was one of those places where the engineers, physicists, chemists, and all the different specialists experimented and eventually succeeded. So the key information file is a document with text and illustrations which tells about the spent nuclear fuel repository in Forsmark in Sweden. The information in the key information file will firstly be about radiation, which is the key danger of nuclear matters. Secondly, it will be about spent nuclear fuel repository itself, what it contains, how it's constructed, and what it might appear on the surface, as this is a deep underground storage site. And most importantly, this key information file is telling something, or is informing about itself, the logic of this document, which is working literally as a key both to more information, but also as a key of transforming information between generations. Much of what is in the key information file is actually about how to keep it relevant and correct in the transfer between generations into the future.
So this file is really aimed at a non-expert audience. It should be something that is understandable to people with no background whatsoever in nuclear waste or even any kind of science or social sciences. It's a document that's trying to make quite technical and difficult information understandable to a wide audience, and perhaps even enjoyable and give them a reason to go back to this information into the future.
If we assume, or for some time, that institutional responsibility for keeping the information of the final repository alive, if it works, then the key information file is the key document for communicating information.
The unique challenge as part of this work on writing a key information file has been really thinking about how can information in archives be kept relevant? How can future generations understand and interpret texts and writing and symbols that are aiming to inform the future about a nuclear waste repository buried underground?
When you think about the time horizon of 100,000 years, which we do in the Swedish case, that is, if you start to think about it, it soon becomes not graspable. It doesn't compare to anything we can relate to. Some people can talk about, for example, 1 or 2 or 3 ice ages before we reach 100,000 years from now, which is of course questioning the existence of humanity, or at least of nation states and the societal organization as we know it today. We have realized that we cannot think about a reasonable recipient of the key information file 100,000 years away. We can think about it, but it's not realistic to think that we could write something which is future-proof in those enormous time horizons.
Over 100,000 years, it's not clear that the human will even be around, and certainly contemporary representational systems, language, signs, all of these things are ineffectual, that they're not reliable carriers of memory and information. So we can think of lots of examples in the past where signs and messages have been incorrectly interpreted or misunderstood. Most attempts at trying to create warning signs and writing to deter people from entering a place have either been accidentally or intentionally ignored or misinterpreted. And part of our work in the key information file has been trying to tap into other methods of memory transfer, not just writing in a text like we're doing, but also think about how other forms of human civilization, culture, have managed to communicate between generations. So everything from storytelling and mythologies to games and playful practices and habits and rituals and religions. All of these things are quite important forms of memory communication and technologies for transferring data and information through time.
Activities integrated in the curricula of schools, different types of ceremonies in the areas where these repositories or this repository will be built. It could be art projects, both physical ones but also performative ones.
In the past, there have been lots of different examples and attempts to think along these lines. Everything from Carl Sagan's Forever archive inside of Voyager 1, which is currently flying out into space and contains a gold record and record player with sounds of human civilization.
Hello from the children of planet Earth.
Archive of photos of people eating and drinking and conducting various kinds of seemingly normal everyday life. But with Carl Sagan's archive, there are clearly some issues, including his attempt to kind of crystallize a kind of universal human experience and universal human life. When you look at the archive today, it's very dated and of its time. There are obviously lots of examples in human history, everything from tsunami stones to hieroglyphics, the Rosetta Stone. These are all really interesting archaeological examples of human society and actually subsequent generations of people finding messages, decoding messages, trying to decipher codes and ideas from the past and create systems of knowledge based on these remains. So examples like the landscape of thorns or spike field or even subsurface markers and surface markers drawing on Edvard Munch's The Scream were used as potential examples of how society might warn off potential intruders. or even accidental intruders to nuclear waste repository sites. So in France, there's the La Zone Bleue proposal, which is used as a genetically modified forest that would glow a green-blue, an eerie colour, very unnatural, seemingly unnatural colour, and that people walking through this blue-green forest would experience a kind of strangeness and a kind of sense of the unusual, the uncanny, which would implicitly inform them through a kind of an affective mood of something that was not right and not normal in this space. Thomas Seebock's proposal for atomic priesthood has also been something that's been taken up by artists and writers with atomic priesthood, is that maybe an actual bloodline, a religion, is the most effective way of preserving an idea or memory of a nuclear waste repository through time. And the whole notion of the atomic priesthood is that this religion, its whole reason for being would just be to communicate the existence of a nuclear waste repository through generations. You can't guarantee that subsequent generations will fully understand or preserve the exact informational idea. And we can think of things like mythologies and stories whose original version has been reproduced and made more sensational and perhaps more exciting precisely because people retold the stories, often around campfires, in kind of spoken word and performed ritual, and it was enjoyable and made sense to add extra details or embellish certain notions and versions and update the information to suit contemporary society.
It's fascinating to think about how will we do that, because we know that hazardous signs will trigger people to go down or whatever, because we are too curious. Soon we have the key information file, or the first one, which is really good. So we can see, so we have something to start with. And I believe that during the years, the next 70, 80, 100 years to come, that is something that we have to work with and see how this should be done together with other companies and institutions that also have to think about this. So it's not, I think it's not an answer we can give now, but it's an answer that we should give when it's time to close the repository. So I think it's going to be people living then, smart people like you or archaeologists or whatever they are going to be, that will come up with the solution.
Of course, the question of will the key information file work is always looming in the background. And many days it's the apparent question is no, of course it won't, which is kind of discouraging. While the energy of still trying comes from the insight that we really have to try. We really have to do our best to make it work. The responsibility for updating the key information file over generations into the future, I think in the first steps is directly connected to the state level. Because the nuclear project, the nuclear energy program was a state project, although it's also transferred to private companies. It's a big societal endeavor, and it's our generations who have benefited from these, from the energy produced. And I think this is a shared responsibility that has to be on the highest level, and a shared responsibility in society, which means that it has to be incorporated in legal bodies, so that it's not up to anyone, an industrial company or a local municipality to decide how to work with this, but it should be on the highest national level.
I think one of the things that emerges in this project, in thinking about perhaps the lack of seriousness around the key information file and how it's prioritized as an element of safety for nuclear waste repositories, is that it also reflects a kind of wider sense that, humanity today is slow at responding to environmental problems, and perhaps are not always responsive and urgent and incisive enough to make meaningful changes to help and remedy environmental problems. So yeah, there's a kind of parallel here between how nuclear waste repositories have been planned, perhaps the lack of societal planning for those repositories, and how societies perhaps struggling to decarbonise and struggling to deal with the sixth mass extinction event on the planet. Hopefully there will be a team of people working on this into the future. But if the key information file is to have any success in informing future generations, there needs to be a concerted effort, not just in Sweden, but internationally, to make these documents, to make them precise, to create certain standards and expectations about what should be included, and to make sure that the information is communicated in a way that's not just for experts, but is something that can be understood by a much wider audience, and perhaps people who have no idea about this topic, but could still be engaged and brought into these conversations in a meaningful way.
When thinking about the future of the repository, which is today not yet built, so it's a bit difficult to imagine what will happen in 100 years when we can perhaps have a finished and closed repository according to current plans. I hope that the current version of the key information file that we are working on will have influenced the process over these 100 years to think about the legacy that we leave to future generations. And I hope that there will be some kind of version of the key information file at the closure of the repository, and I hope it will make a difference. I'm not sure on which time horizon, but I hope it will make some kind of difference.